All right, good afternoon, everyone. Thank you for joining me today. My name is Moez. I'm a product manager at Zebra, and I'm really excited here to be sharing the work that my team is doing for the last couple of years. So Zebra has been enabling the front line of retail and CPG companies for over 50 years now. Um, we have worked with more than 80% of Fortune 500 companies. We have worked with almost every large retailer in the world. You probably know Zebra from its hardware devices like scanner, printer, handheld. But since 2019, Zebra has started to acquire a portfolio of software companies so that we can increase the value that we deliver to our customers. And I came to Zebra as part of that acquisition in 2021 through Intuit.ai. And what Intuit used to do is build forecasting solutions for retail and CPG companies. So let's start with the why, right? This is a survey from KPMG where 60% of CPG executives feel that accurate forecasting is the number one challenge preventing them to achieve a profitable and resilient supply chain. And if you look at the other challenges on this slide as well, they are all mostly related to accurate forecasting, and kind of makes sense that if your forecasting is bad, all the downstream decision making is going to get affected. Now, if we are able to achieve accurate forecast, what do retailers and CPG do with these forecasts, right? It turns out that forecasting is used across the board for decision making, whether it's inventory planning, manufacturer planning, whether it's marketing and promotion, pricing decisions, product placement, or even new product launches. Forecasting is the underpinning ingredient to convert some of these use cases into six-figure, seven-figure ROI for your companies. Forecasting has fundamentally changed over last decade. We have gone from really high-level static batch weekly forecast powered by limited computing to this infinite compute, cloud scalable, SKU store daily level forecast, right? And as we move from forecasting in 2025 has become a hyper technical exercise, and we see a problem in that because the more technical forecasting becomes, the further it moves away from the business, right? And even with companies with very resourceful and really large, great data science teams, building accurate forecasting model at a scale and be able to maintain the accuracy over a long period of time is far from easy, right? And it's not because that algorithms and models that we have today doesn't work. It's because the disproportionate amount of time teams have spent in setting up infrastructure, tuning infrastructure, doing deployment, MLOps, everything except for thinking about how can we maximize the business impact from these accurate forecasts. And this is the problem that we are this is the problem that we are trying to solve with our platform called Workcloud Modeling Studio. Workcloud Modeling Studio is a no-code, low-code machine learning platform targeted for data science teams in retail and CPG companies to be able to train, test, and deploy highly scalable machine learning forecasting pipelines. Now, looking at this screen, the tool looks pretty intuitive. Almost all the workflow tools work like this. You visually build a pipeline, except that one thing you would notice on the left-hand side that you see those small boxes, those are steps or operations that you can perform in Modeling Studio, right? So the idea is very simple. The application comes with a lot of algorithms, pre-processing steps, feature engineering that data science teams can use to visually build this without writing any single line of code. This is a high-level blueprint of the platform. In the middle, you see, the first thing you'd see, the platform sits on top of your Databricks. So if you are a Databricks user, spinning up Modeling Studio is going to be very easy. the data and the infrastructure is provided by Databricks, right? So your data never comes out from your infrastructure. And whatever you do in Modeling Studio is single tenant Zebra hosted UI, but underneath it is going to use your existing Databricks and Data Lake infrastructure. What you are seeing on right are different use cases of forecasting. Once you generate a forecast, you'd be able to sort of use them for allocation, replenishment, or all these other use cases that you have. All right, with that, I am going to change my screen to show you the platform. This is the landing page of the application. You can see a search experience on the top. You can see documentation links on the right, some recent in the middle. You have left-hand navigation on the left-hand side. For the first time when you start Databricks, you would have to go and create a developer token in your Databricks account and pass that developer token here. That's how we are able to sort of create the compute and everything in Databricks on your behalf. And this is just a one-time thing. But once you have done that, the first thing normally people would do is create a compute resource here. This experience is pretty similar to Databricks. You can simply click on a create compute button, give a name, set a resource, and you can click on create. As you can see, I have a few compute already, and 2 of them are running, right? And if you go to your Databricks account, you would be able to see logs in real time for these compute because these are actually running in your Databricks account, right? Once you have compute set up, what you do is the work in Modeling Studio is organized in projects. Project is the highest level in hierarchy. All the data, experiments, pipelines, artifacts belong to a project. And I have a couple of projects here, right? And all the work that you do, right, can be either only limited to you or you can share with across other teams in your organization. So the tool is built to support the collaboration and partnership across teams as well. So what I'm going to do is I have a project here called Databricks Demo, right? And it has 6 steps. I've built this 3 days ago. This is a anonymized data set, but it's a forecasting use case where I have a data set of actual SKU store level with a lot of promotion signals, calendar data, and all this different sort of data. The project is organized. It's a typical way to organize a project, but it's up to user. But there are 6 steps in this process, starting from pre-processing. The second step is feature engineering. Then we are training a very simple light GBM model. Then we are predicting it. And then finally, we are preparing the final output, right? So if I open the first experiment, so we call this a screen canvas, right? You have seen this before. On the left-hand side, you have all these different steps. We call them transformers. They are the original implementation on Spark, right? So what is really unique here that this is actually running off your compute in Databricks, and all the implementation, whether it's join table or filter table, whether it's a light GBM model, whether it's a promotion model, whether it's a time series decomposition or a ARIMA, everything is natively implemented in Spark so that it's very cost efficient for you and it's scalable, right? So this pipeline is very generic, just joining a couple of data sources. I'll show you a few of them. For example, this one. Right, this is my calendar table. You can see I have all these different events here, 75 different columns, 1900 rows. I have just a hierarchy, item, department, category hierarchy here. And I believe this is my fact data. You can see this is 59 million records. It took me about 2.5 hours to run the entire thing that produced a forecast. Very good forecast indeed. So this step is very generic. Pre-processing, just filling missing values, joining tables, and basically preparing the data set for the next step. If I bring up step 2 here, this is a little bit more data science-y. So what this is doing, the 2 main things, sorry, I opened step 1 again. So the 2 main things that this step is doing is, it's very common that you have a lot of zeros in your data, in your sales data, and that may not necessarily mean no demand. It may mean out of stock, right? So this is a pretty common technique where you try to detect what are the days where you are out of stock, because your goal is to predict the demand, not the sales, right? So we have a proprietary implementation of these algorithms here that can do that job for you and create a flag in your data set so that you can then impute them with some realistic number instead of zero. The other thing that is also very sort of common in retail is you don't just have units sold, but you also have a lot of promotional data, event data, like was the unit on sale, some kind of promotion on that day, what was the weather like, right? Depending on what you are forecasting, there could be a lot of exogenous variables, right? And when you are using some sort of regressor model to forecast, what you have to do is you have to take the effect of all those exogenous variables out, predict the base demand, and then join them back, right? So this is what this step is mostly doing. It is basically removing the impact of all the other events that we have in our data sets so that we can forecast the base demand with light GBM model, and then at the last step, we are going to add it back. All right. The third step, after I have removed the effect of promotion, removed the effect of other exogenous variables, this step is simply just throwing that processed data set into a light GBM model, which gets sort of used in step 4 that produces the forecast, right? So this is what we were after, the final output. Right, and you can see there's depromotionalized sales unit decomposed, and the step 5 and 6 just sort of adding it back, connecting it together, right? The really good thing about this, as you are doing these experimentations in Modeling Studio, you can, all the output that you produce here is basically an artifact that you can see here, and this artifact is essentially a Parquet file sitting on your Databricks, right? So basically what you can do, for example, this is what I did. I loaded in the final output in my Databricks notebook and just visualize here. So this is the forecast that I produced at an aggregate level. The orange line is the forecast, right? And this is more at an item level. So anything that you produce in Modeling Studio, you can very easily switch back and forth between Databricks and Modeling Studio, right? The other thing I would say that once you sort of do your experimentation here, do your model selection here, it is very easy to simply deploy this pipeline, at which time you set a schedule, and this pipeline would basically run as a Databricks job in your Databricks account at a set schedule. If you want, you can monitor them in Modeling Studio UI, but these jobs would also be there in Databricks account. If you feel comfortable, you can also monitor the jobs from there as well. All right. Coming back. So if you have a forecasting use case in your company, if you are a Databricks customer, right, this is going to we think this is going to maximize or increase the value that you are getting from your infrastructure, right? And if you're interested in trying, we are giving free trials. You can sign up a quick form. It would take you 10 seconds, and somebody from our team would reach out, and we are happy to set a more detailed data science demo, and we are happy to give you a trial to try it out. Thank you so much, everyone.